This video will show you how to create a kinematic simulation. First, we will see how to import the kinematics behavior of a Katya assembly in the Dimela behavior modeling app, then we will create a kinematic simulation for the assembly. Let's launch the Dimela behavior modeling app. We will open the robot assembly. If the assembly appears in gray, click on View Modes and disable Use Object Material. Let's go back to Dimela behavior modeling. We will create a new package to store our Modelica classes. To create a new class, navigate to the Behavior Authoring tab and click on the New Modelica Class button. Name the new class, Tuto Kinematics. Set class type as package. Click on the rubber to insert it in the root folder. A package called Tuto Kinematics has been created. Now, let's create a new Modelica class. Name it Kuka Kinematics. Class type is model. Insert in the package Tuto Kinematics created before. For that, click on the package in the tree. Now, let's import the kinematics behavior of the assembly. In the Behavior Tools tab, click on Generate from Kinematic. Click on the Mechanism field, then on the mechanism in the assembly's tree. Insert in the package. Name it Kuka Kinematics Imported. Enable Update Mass and Inertia on parts before translation. As the model contains parts with mass equal to 0, this warning appears. Don't worry about it. The kinematics behavior has been imported in Dimela. Now, let's create a kinematic simulation. The pivot connections must be set for kinematics. Set rotation control to by position. Do that for all the 12 pivot connections. We will create interfaces to have inputs and outputs to the simulated model. Search a frame B. Drag and drop it in the model. Connect it to the model. Drag and drop a fixed translation, a fixed rotation, a frame A, an absolute sensor from Mechanics Multibody Sensors, a real output. Connect the blocks as shown. Between the tool and the fixed translation, set 1 in the window. Enable getter in the sensor's parameters to measure the absolute position vector. Set the output Y as a vector of size 3. Set the fixed translation to 290 mm on X, 0 on Y and -85 on Z. Set the fixed rotation as n equals 0 on X, 1 on Y, 0 on Z with an angle of -90 degrees. Now, you can drag and drop the imported kinematics model into the class Kuka Kinematics to use it through the interfaces. As you can see, the skin of the kinematics behavior class is messy. It is possible to edit it by clicking on Icon Layer. Then, you can add text or images and also move the interfaces in order to make it easier to understand. The class's icon is now well organized. Now, let's create a class of type model. Insert it in Tuto Kinematics. Drag and drop in the new class, a constant. Set it as a vector of size 6 and set the value to 0. Drag and drop a position from Mechanics Rotational Sources. Set it as a vector of size 6. Finally, drag and drop a flange B and set it as a vector of size 6. Connect all the blocks as shown. This class will set 6 pivot connection to 0 degrees. Drag and drop the new class in the imported kinematics class. It may be pimped as the previous one. Connect it as shown. Now, we will manage the control of the kinematics model. Let's create a new class called Kuka Set Pos Core, of type model. Insert it in Tudo Kinematics. Drag and drop a constant, a real input, an add, a gain, a block called from deg, a position, a flange B. Set all blocks as vectors of size 6. Connect all the blocks as shown. You can set an offset and change the sign of the rotation movement by changing the value of the constant and of the gain. The class can be pimped. Drag and drop it in the Kuka Kinematics class and connect as shown. This class takes 6 values in input and will move the robot's assembly to the desired position. The constant and the gain can make slight modifications to the values if the start values aren't set well. Now, we will create interfaces to control the simulation in real time. Drag and drop 6 inputs. Name them with numbers between 1 and 6. Connect them to the reel-to-pos block as shown. Drag and drop 3 outputs. Name them X, Y and Z. Connect them to the XYZ output. The class can be pimped to be easier to use for simulation. Now, let's use our model for kinematic simulation. Create a new class called Simulation. Class type is Model. Insert it in Tudo Kinematics. Drag and drop in it, Kuka Kinematics. Drag and drop a constant. Set it as a vector of size 6. Set as value the desired position for the robot. Connect it as shown. The simulation's parameters can be set in Simulation Setup. Click on Simulate to start the simulation of the model. The robot is in the position set in the constant block. In the simulation's result, the output XYZ are the coordinates of the tool. We can do a moving simulation by creating a variable input such as a ramp. Delete the connections between the simulation block and the constant. Drag and drop a ramp. Set it as a vector of size 6. The same final position will be set and the ramp will make a linear interpolation between the 0 position and the final position. Connect it as shown. Let's start the simulation. As you can see, the robot is moving. Let's summarize what we have learnt during this video. First, we saw how to import a kinematics behavior from a Katya assembly to a Dimela behavior model. Then, we saw how to create a kinematics simulation in the Dimela app. In the next video, we will see how to create an inverse kinematics model.